Hello there, Mr. Sutton here, bringing you the IM351 Extra Practice Number 3 solutions on solving polynomials by factoring. In this one, we are trying to solve a puzzle as well. Let's see what that's all about. So here's the puzzle I'm trying to solve by doing this extra practice. We're trying to answer the question, who wrote the book Split Personalities? So what we have to do is figure out the solutions of all these different equations, and then when we see the solution down below here, we have to put the letter that goes with that solution above the blank that goes with the problem number. So for example, if I do problem number 1 and I see that the solution is 2 and 3. I don't know if it is, but if that's the solution, then we would put the letter R above spot number 1 down here. We also have to be a little bit careful because it looks like some of these might be repeated. So you might get more than one spot with a single letter. So let's go ahead and see what that answer is going to be. So here we go with the first problem. Now our strategy on all of these problems is going to be more or less the same. We're going to factor the polynomial and then set each of the factors equal to 0 and solve. And taking a look at all of the different answers, it looks like I ought to be able to get all of these by factoring completely. I'm not going to have to do like a square root of anything and get some crazy radical answers. So for this first one, since I don't have any coefficient next to the x squared, I can just do like regular factoring, basically asking what are factors of -8 that add up to -7. We got 1 and 8. That would work if I have +1 and -8. So let me rewrite this then as x plus 1 and x minus 8. And now I'm going to set each of these equal to 0 and solve. Basically figure out what I need to plug in for x to 0 out each of these factors. So for the first one, I need -1, and then for the next factor, 8 minus 8 would give us 0, so 8 is our other answer. -1 and 8 is actually the very first top left letter there, so that's actually kind of nice. So we're going to put a D wherever I see 1, and there's only one of those right there, so that's a D. Okay, let's keep going with our second question. For this one, I want factors of -6 that add up to -5. So 1 and 6 will do the job. I didn't have to search too long to find those. I need +1 and -6 to add up to a -5. So x plus 1, x minus 6. And then zeroing out each of these factors, we end up with -1 and +6 for our two answers. -1 and +6, that's, let's see, +6, -1, that's right here with u. So u is going to be what I put in spot number 2. So if you thought that this puzzle was going to be a piece of cake based on the first two questions, question 3 is kind of a wake-up call. This is going from nothing to nuclear in one question. We no longer have just a 1 next to the x squared. We have a 6, and we don't even have this whole thing zeroed out. So very first thing I'm going to do so I can use my zero product property is subtract 36 to get in standard form. So we have 6x squared plus 15x minus 36. Now, before I just go straight to the AC method or guess and check, let me see if there's a common factor that I could divide all of these by. They're all even. Well, they're not all even. 15 is not even, so I can't divide by 2. 3 would actually go into all of these. Could I get 6? Nope, because they're not all even. So if I divide all of these by 3, that'll give me 2x squared plus 5x minus 12 equals 0. And although this is not great, I mean, I still have something that's not a 1 in front of the x squared, this is at least smaller numbers to work with. So using my AC method, I'm going to do 2 times -12 to get an AC value of -24. And now I'm going to be looking for factors of -24 that add up to 5. Let me think here. We got 1 and 24, 2 and 12, 3 and 8. If I have -3 and +8, that adds up to +5. So let me split up this 5x into a -3x plus 8x. And now I'll do factoring by grouping since I've got 4 terms. First 2 terms I can take out an x. That leaves me with 2x minus 3. And for the second pair I can take out a 4, leaving me again with 2x minus 12 divided by 4 is 3. So then 2x minus 3 is my common factor that comes out of all of that. And then x plus 4 is my leftovers going next to it. Now zeroing out each of these factors individually, if 2x minus 3 equals 0, I could add 3 and then divide by 2 to get 3 halves as one of my answers. And then for x plus 4, negative 4 is going to zero that out. So 3 halves and negative 4. Let me scan to see where that is. Oh, right there. That's going to be a y, and that's going in spot 3, and there's only one of those. So there we go. On this next problem, let me begin by getting this in standard form by moving everything over to the left side. I guess I could move things over to the right, but then I have a negative squared term, and that's kind of a pain. So I'm going to rewrite this as 12x squared minus 17x minus 7 equals 0. There's no common factors I can divide by or factor out, so let me go straight to AC method. 12 times negative 7, that's an AC value of negative 84. So now I need factors of 84 that add up to negative 17, or negative 84 that add up to negative 17. 1 and 84 obviously won't work, neither will 2 and 42. 3 and, let me think, I think 3 and 28, that gets me closer but not where I need to be. 4 goes into 84 21 times. Well, if I had a positive 4 and a negative 21, that would add up to negative 17. So let me break that up into a 4x minus 21x. And now it's up to the grouping process here. So for 12x squared and 4x, I can factor a 4x out of both of those. That leaves me with 3x plus 1. And for this next pair, I can take out a negative 7, leaving me with positive 3x plus 1. 3x plus 1 is our common factor coming out. 4x minus 7 is our leftovers going in. And now zeroing each of these out, for the first one, if I subtract 1 and divide by 3, negative 1/3 is going to be one of my answers. And then for this next one, I have to add 7 and divide by 4 to zero that out. So that's going to be 7 divided by 4, 7/4. So negative 1/3, positive 7/4. And that is going to be right here, A. So that's going in spot 4. There's a 4 there, and I don't see any other 4s, so we're moving on to the next one. This next problem is a little bit of a game changer. The first 4 questions, you could have actually done all of those with quadratic formula. This one, you have to factor. We can't just spam the quadratic formula on this one. So we'll start, since I see both terms have an x, I can factor out an x from both of those. That leaves me with 4x squared minus 1. And looking inside here, I notice that I have 2 perfect squares with a minus between them. So that fits the format of a squared minus b squared, which I can split up by square rooting both of these things and putting a plus and a minus in there. So I've got the x that I initially had. The square root of 4x squared is 2x. Square root of 1 is also 1, so we have 2x plus 1 and 2x minus 1. And now I can set each of these equal to 0 and solve. So if x equals 0, well then x equals 0. So that's one of my answers. 2x plus 1 equals 0. Subtract 1, divide by 2, that's negative 1/2. 2x minus 1 equals 0. Add 1, divide by 2, so positive 1/2. So we have plus or minus 1/2 and 0. Let's see if they wrote it in that format. Let's see here, 0, 0, 0. There it is, 0 and plus or minus 1/2. That's an n going in spot number 5, which is right over here. This next one is going to be a fair amount of work. I notice that all of these have x's in them, so I can at least take out an x. Can I take out any common factors for the coefficients? Doesn't look like it. 12 and 3, I could take out a 3, but this 16 is kind of messing us up with that. So let me take out an x and go from there. We've got 12x squared plus 16x, and then minus 3. And now this stuff inside, there's no perfect square shortcuts I can take, so I'm going to use the AC method then. That's an AC value of 12 times negative 3 is negative 36. So I need factors of negative 36 that add up to 16. 1 and 36, 2 and 18. 2 and 18 could work actually if I have negative 2 and positive 18. So let me split that up into negative 2x plus 18x. Now I'm going to use some grouping on the stuff inside. So I've got the x that I took out initially, And now for the first two terms inside here, I can take a 2x out of both of those. That leaves me with 6x minus 1. For the next two, I can take out a 3, leaving me with 6x minus 1. So I have the x, I have this 6x minus 1 that comes out of both of the terms inside here, and then the 2x plus 3 is my leftovers going in that last factor. Zeroing each of these out, we've got x equals 0, and then we add 1, divide by 6, that's 1 over 6 for that middle factor, and subtracting 3, dividing by 2, negative 3 halves for that last factor. So 0, 1 over 6, negative 3 halves, that's right up here, that's going to be a C, and so that's going to be what I'm putting in spot 6. For number 7, I noticed that there's no common factors that I can take out of all 4 terms, but I also noticed that there are 4 terms, so I can use factoring by grouping right away. First two terms, let me take out an x squared. That leaves me with an x plus 3. And then for the next two, it looks like I can take out a negative 4, leaving me with an x plus 3 again. So then x plus 3 is my common factor coming out. And then we have x squared minus 4 going in. And I can break this down a little bit further. So I can do x plus 2, x minus 2 for that x squared minus 4 business. There we go. And now zeroing everything out, we have negative 3, negative 2, and positive 2. So that's negative 3 and plus or minus 2 is probably how they'll write it, just to save space. Let's see here. Plus or minus 2, where do I see that? Well, that's plus or minus 1/3. I don't want that. Let's see, where else? There it is, negative 3 plus or minus 2. A lot of these look very similar, but that's an L going in spot 7, and there's only one of those right there. For this problem, let me start by zeroing this out by getting 81 over to the left side. I'll subtract it. And I noticed that we've got two perfect squares with a minus between them, so I think this is one of those a squared minus b squared kind of situations. The square root of 25x squared is 5x. Square root of 81 is 9, so we have 5x plus 9 and 5x minus 9. And if I zero each of these out, for this first one I would have to subtract 9 and divide by 5, so negative 9/5. And over here this will just be a positive 9 divided by 5. So plus or minus 9 over 5, pretty easy to spot that. That's right here, that's an E. So that's going in spot 8. But wait, there's another one over here. But wait, there's another 8 down here. So we got a lot of mileage out of that one problem. Good for us. So for number 9, there's a lot of things going on. First, we need to get this in standard form. So let me subtract 37x squared and add 4 over to the left side. Next up, this is in something called quadratic form, where you have an x to the 4th, an x squared, and a constant. You can basically factor it like you would a regular quadratic, only you have to use x squared instead of x in your parentheses when you do that. And you could try to use perfect square shortcuts on this, but if you do that right off the bat, you'll see that you don't end up with a middle term of 37x squared, so we do end up needing AC method on this. So 9 times 4 gives me 36 for the AC. Things that multiply to 36 and add up to 37, that's going to be 1 and 36, both negative if we get negative 37. So I'm going to split this up into negative 1x squared minus 36x squared. Now I'm going to use some grouping because I've got 4 terms. First two, I can take out an x squared. That leaves me with 9x squared minus 1. For the next two, I can take out a negative 4, leaving me with positive 9x squared minus 1. So then 9x squared minus 1 comes out. X squared minus 4 is my other factor. And I can actually split these up further, which I'm going to do. These are both a squared minus b squared perfect square situations. So for both of these, I can do a plus b, a minus b type setups. For the 9x squared minus 1, square root of 9x squared is 3x. Square root of 1 is 1, so 3x plus 1, 3x minus 1. And then moving on here, square root of x squared is x. Square root of 4 is 2, so x plus 2 and x minus 2. Now I can zero each of these out. For this first one, 3x plus 1, if that equals 0, I would have to subtract 1 and then divide by 3. So I'd end up with negative 1/3 for that answer. And then positive 1/3 for the next one, since that's the only difference is the sign. And then to zero out the last two, I need negative 2 and positive 2. So I have plus or minus 1/3, plus or minus 2. I see that over here with the letter Q, so that's what's going in spot 9. For number 10, I see that I have 4 terms, so factoring by grouping looks like a good way to go on this. Before I do that, though, I notice they're all even, so I can at least divide them by 2. So if I do that, I've got 2x cubed minus 1x squared minus 18x plus 9 equals 0. And now grouping here, we can take an x squared out of the first two, leaves me with 2x minus 1. And then for the next two, I can take out a minus 9. That'll be a positive 2x and a minus 1 left over there. So 2x minus 1 comes out of everything. And then x squared minus 9 is the other factor. And with x squared minus 9, I actually can factor that further if I want to using a squared minus b squared, a plus ba minus b. So I've got the 2x minus 1 that I took out initially. And then square root of x squared is x. Square root of 9 is 3, so plus 3. And then we have an x minus 3. Zeroing these out, first one I'm going to add 1 and divide by 2, so 1/2. And then I get a negative 3 and a positive 3 to zero out the next two. So 1/2 and plus or minus 3. Let me see if I can find that here. Looks like that's going to be j right there. So that's going in spot 10 right here in the beginning. So it looks like I have a hunch what this is going to end up being for the final answer, but let's just see this thing out. This next problem is a little bit of a pain. They're giving us something that's zeroed out, but it's not in standard form, so factoring this is going to be a little bit annoying. I'm going to actually just change all the signs, so basically multiply everything by negative 1, or you could think of this as moving everything over to the right side. So I'm going to end up with a positive 10x squared plus 36x and then a minus 16. And I'm just going to write equals 0 over on the right because writing 0 equals all of this just looks cringy. Now I'm going to take a look at my numbers here. I can't take out a 10, but I can at least divide all of these by 2 because these are all even numbers. So that'll make my life a little bit easier. So we've got 5x squared plus 18x minus 8 equals 0. And I'm just going to go to AC method on this one. You could use quadratic formula as well. So 5 times negative 8 is negative 40 for the AC. I need factors of negative 40 that add up to 18. 1 and 40 doesn't do it. 2 and 20 does if you have a negative 2 and a positive 20. So let me break this up into negative 2x plus 20x. And then using grouping, first two terms, I can take out an x. That leaves me with 5x minus 2. For the next two, I can take out a 4. That also leaves me with a 5x and a minus 2. 5x minus 2 comes out. X plus 4 is the other factor. So for this first one, we're going to add 2 and divide by 5 to get 2/5 as one of our answers. And then minus 4 plus 4 zeros that one out, so negative 4 is our other answer. So let me see, 2/5, negative 4, that's down here in the bottom left, that's an I, so that's what I'm putting in for 11 here. So here it is, number 12, final boss battle, last question to see what letter goes for the first letter in that second word. So looking at these, I noticed that they all have an x, so I'm definitely going to take that out. And they're all also actually divisible by 3, so let me take a 3x out. That leaves me with a 6x squared minus 13x, and then this will be a minus 8. So I'm going to have to do a little AC method on the stuff inside there. There's no way around it. 6 times negative 8 gives me negative 48. So I'm looking for factors of negative 48 that add up to negative 13. We got 1 and 48, 2 and 24 doesn't do it. Let's see, I think 3 times what? 3 times 16, that also doesn't work. What else do we have? 4 times 12, that's getting us closer. And then, what else am I missing here? we've got 6 times 8. I feel like there's something fundamental I'm missing. Adds up to 13. Well, they have to subtract to give me 13. Oh, 3 and 16. That's what I need. Only I need them to be subtracted. So if I have positive 3x, negative 16x, that would do it. All right, now we're good. So I've got the 3x I took out initially. I'm splitting this 13x up into a positive 3x and a minus 16x. There we go. So there's the 3x. Let me use some grouping on the inside now. First two terms, I can take out a 3x from those. That'll give me a 2x plus 1. And then for these next two, I can take out a negative 8. That leaves me with 2x plus 1. So I have the 3x I took out before. I have the 2x plus 1 that I took out of both of those terms. And then I have the 3x and the minus 8 that are left over. Zeroing each of these out, 3x equals 0, so x equals 0. 2x plus 1 is 0, so adding 1, or subtracting 1 rather, dividing by 2, we have negative 1/2. And then for 3x minus 8, if I add the 8 and divide by 3, I've got 8 over 3. And then looking for those three things, I see them with h, so we have an h for spot 12. And now at long last, we can solve the puzzle. So it looks like this first thing is actually all one word. This is a name, Jacqueline, and then this last one could only be the name Hyde. So who wrote the book Split Personalities? Jacqueline Hyde. Get it? Like Jekyll and Hyde. Anyway, till next time, Mr. Sutton, I got a split. See you later.